afternoon, foggers. This is totally spontaneous because there it is. There it was. And the sun has just gone down behind us. Okay. Now, right, see that moon, right? You might just be able to see me. Right. Here's the story so far. That moon up there, it's coming towards us, but it's not. That moon is moving away from us that way. It's actually going that way. But we on Earth are spinning faster than it is getting away from us. Okay? So Australia is there, right? Now, look, we need to go that way, I do believe. We're here. We're about here, okay? As you can see, excuse my hands, I just done the brake pads on my bloody scooter. See that moon? It's in the sky. It's probably going to be, right, that's facing north like that. It's probably about right. Okay, so you see that moon up there, right? So what's happening? That moon is moving away from us. It's moving away from us, but our spin, right? It's so fast that it's going to give the appearance that it's moving. It's going to come over us, right? And follow the sun. That's what's going to happen. Not because the moon's moving, but it is, right? But it's our speed, right? Sorry, so I can't feel the spin. By this time tomorrow, this time in the afternoon tomorrow, we would have spun 360 degrees. The water? Seriously? Now the sun, it's setting. Can't see it now. If I got up onto the roof of the house, I'd probably be able to see the sun, right? Now the reason it's going that way is because we're spinning. We're spinning towards the moon and the sun. Everything is going to go because we're spinning. Does it feel like we're spinning? The moon is traveling at, what is it? 2,300 miles per hour. I think that's about right. Away from us. And at the equator, we're spinning 1,000 and a bit miles per hour. But because we, obviously, that our 1,000 miles doesn't have anywhere near as far to go as the moon's 2,300 miles. So we overtake it because it's got a longer arc, right? And we've got a shorter arc. So we overtake it and it will go, phew. Really? Now, on the flat Earth, what is said is we're not moving. We're not moving. What's happening is the moon is coming over us. And when the sun comes over, it's going over us. It shifts. What they're saying is it shifts, right? So it's been up there. Now it's going to come down to about the equator line, the sun, right? And then it comes down south of the equator, right? So we have Cancer. Oh, I can't remember which one's which now. I think it's Capricorn is at the top, Cancer's at the bottom, I think. Anyway, this is where the sun shifts from here to there and not too far away, okay? So, what is it we see when we're looking at a solar eclipse? We see it from here, it would be the moon is going, here's the moon, here's the sun, and it goes like that. But up on your end, in the northern hemisphere, you see the sun, they make the sun and the moon comes like that. Don't you? You see it go like that. Right, mate? Like that. And the reason that's happening is because we are spinning that way. But flat Earth, it says, the sun, we're not moving, they are both moving. The sun that is setting now over in the west is going to come around and come back up. It is moving a little bit faster than the moon. Once a month, the sun catches up with the moon, comes behind it, and overtakes the moon. So in the northern hemisphere, what's really happening is you're not seeing the moon go like that. Like that. Boom. That's right, isn't it? Yeah, in your northern hemisphere, you see that. Boom. That isn't happening. What's happening is the sun is overtaking the moon. Now let's go and have a look. It's popcorn time. We're going to go. I found a very rare, genuine bits of solar eclipse footage. And there is a twist at the end of this. Here we are, okay? Now this is, just looking at eclipse things, because I can't get enough of them. I'm never happy with what I see. Now there's a couple of bits here. Right, it's take 10, 11 minutes. This is the Spain, right? We've just seen. Now look. This is the sun going faster than the moon, not the moon see how they're both moving to the right. Look. Now, hang on, that's just the little taster. Right, now there's a couple of things here. A couple of things that start to get a little bit. Now what's that doing down there? This is the realest bit you'll ever see. Watch this. It's coming up in a second, I hope. There it is, there it is. Watch this.
You can guess what it's going to be like, but at the end you have to live it.
You have to live it.
We try and make there, so whatever it's gonna.
Here we go. In. Now let's slow that down. This, for me, it's rare because it looks real. This is what is happening. Now look. The sun is behind the moon, it's catching up to the moon behind it. And bam! It's behind it and now it moves ahead of it. It overtakes the moon. Let's watch that again. It's very rare because all of them, they seem to kind of keep the sun still so that it looks like the moon is going from right to left over the sun's face. It's not. It's the sun catching up to the moon behind it and overtaking it. How is this us spinning? It's obvious that it isn't. Right, now hang on, there's more. Where's this one? This is when I was like, hang on a minute, what's going on here? Now, watch this. Oh, no, keep going. Right, we're nearly there. Now, what you're seeing here is the view from inside the plane. It's one of those cameras, wide angle. That's the rear of the plane, right? That's the front of the plane, and that's the middle of the plane. And they're all looking out of the right-hand side windows. It's an eclipse flight over Spain, right? Madrid. Watch. So they're in a plane. Now, I was thinking, why is it going so slow? I'll tell you why, because I slowed it down. I'm flipping it up to real speed. Look. Did that look real? Now, what have we got here? Look at that curvature! We are at a cruising, you can see that they are high up. How is it possible that it's got to be at least 30,000 feet high? That they are able to see the same solar eclipse as the people 33,000 plus. Between 33,000, 37,000 feet. How is it possible that they're seeing an eclipse above Spain at the same time as below them, 30-something thousand feet, the people on the ground are? Now this is when I started to get a little bit, what's going on here? The curvature. Let's get one thing really, really straight here. All right? You can see that curvature, can't you? What's that dangling? Oh, God, I've got this fucking screw dangling. Oh, that was there all the time. I hope that hasn't confused any of you. Sorry about that. Anyway, it's just a random screw. Those were the days, eh? Oh, did you say that out loud? Where's the other photos? Hang on. Oh, what have I done with them? Show Kristen, that's what. Let me pause you. Here we are again. Right, now, see that look at that curvature, right? Now, this here, taken by moi on the way to, I think it was the Falklands or Canada or somewhere. It's an RAF jet, so I think it was probably passenger plane, RAF plane. So now, this is where I started to think, what's going on here? These aren't doctored image, no fish eye lens, nothing, right? So straight away, it seems that we've gone from some really cool footage to a little bit Mickey Mouse, right? Because that is not possible. Forget the curvature. The fact that they're up 30-something thousand feet and seeing the same eclipse as they're seeing down on the ground. There is a thing called common sense. And that would be highly illogical. In fact, not illogical, impossible. Now, let's keep going. What's that green thing? I'm there. Right, hang on. Look at this. Let's slow this down. what are we seeing here? See, all of a sudden, I went from real at the beginning to I'm not sure what. I'm coming here with you guys just to make sure that you're seeing. I've got a habit of not zooming proper, haven't I? Or forgetting to zoom at all. Now watch this. What are we seeing here? Look at that moon. See, I'm thinking, what? We have gone from some seriously cool footage, right, to a little bit Mickey Mouse-ish, I'd say. Now I'm going to fast forward. Like I said, there's a twist to this. Now where's the next one? It's more of the same. Okay. Germany. You can see how everything is happening from the bottom right hand side of the sun, right? Now, look at this. Now what we're going to see, it's almost as if everything, we're watching it from Spain, right? Right there. We're facing the west. We're facing the US. It's over the Atlantic, all right, from Spain. To the left of us, we have Africa. To the right of us, we have Scotland, right? The UK, France. Behind us, we have Italy. We're in Spain. Now, what's going to happen, it's going to be like we've shifted down to West Africa, right? And we're still looking at this eclipse, but from down here. Now watch. Now look. Why have we gone from the sun or the moon coming up from the bottom left kind of a thing, or the sun coming down onto the moon from the top left? Bottom right, moon coming into the sun, top left, sun moving behind the moon. Now, what's going on here? What is this we're watching here now? Right, so we go forward. It's like saying, what's going on? And then, see, we've got news.com.au up here the whole time. Right? But was it .com.au? Timeanddate.com. Leon, Spain. Palma de Mallorca, Spain. All of a sudden, we find that Stavanger, Norway. Timeanddate.com. Listen to the music even. saying that music, but it was a lot to do with the speed. But it shifted to timeanddate.com. So wait.
How time can be different.
Leon, Spain. So now what we have, well, hang on, Stavanger, Norway. We're further north. Now, Palma de Mallorca, we're further south. Who knows where this is now? So first we have it coming out from the middle, right? Right? There, look, see? Center right, and then it shifts. And watch, bottom right. And now, some cloud cover. Folks, this here, not the aeroplane bit, that was an absurdity. This bit here, where is it? This. For me, this here, look. That right there is as real as it can get. Brian May. Sun is overtaking the moon behind it. It isn't the moon coming into a static sun. Bang! It clears the moon, overtaking it on its trajectory, bottom right hand side. Earth's spin. Earth's spin. Sun's catching up to the moon. Bang, covered it. Bang, overtaken it. That right there is as real as you can get. You can see the people in the background. You can see that structure, right? That doesn't move. The dome, is it like an observatory or something? And right there, us spinning. And how would we be spinning for that to happen? We're spinning in such a way that the moon is coming above us. Now, how does that work right there? And this here is where the shadow, the moon shadow, started up in Russia, in Siberia. How? So Siberia right now is up to the right-hand side of us, isn't it? How on earth would they have already had shadow on a round Earth? How on earth would they have had a shadow? They would have gotten the shadow when see, we're backtracking. We start there and it comes down, doesn't it? Right? You have to see this, right? We're going to hit playback speed to normal speed. Now look. Dropping, bang! Now, they would have had the shadow up in Siberia before this moment. The sun, moon is there, the sun is over here, and it's coming towards the moon. When it's fairly close to the moon, the shadows would have been shooting up just over Iceland, over the North Pole, right? But how can it on a globe? It can't, because of the curvature. It would have to be flat, because it would not go. It would not reach that far because of the curvature. We're seeing all of this action down here, right? UK, there's Spain, and it's coming like this, isn't it? This is what's happening. So the moon's here, the sun is coming from this direction, or something like this. Moon, sun is coming towards it right here. This is the moment that the shadow would have been up here. But on a planet with curvature, there is no way that the shadow is going to reach up to here. And then the moon comes around, the sun comes around with it, overtakes it, bang, somewhere around here. And that's when you see the curvature here. So we've passed where the shadow is here. As soon as the sun comes behind the moon, bang. And then as the sun overtakes the moon, the light, it goes like this. Moon, sun overtakes the moon, and the shadow is going. And let me pause you just to finish off with what I mean with the flashlight and the moon. Here we are, 27. Right, we're going to do this before 30, right? So what we have, the moon was coming along like this, wasn't it? Right? Everybody's looking to the west, and the sun is behind the moon somewhere, and the shadow is up in Siberia. It comes around, they both come around, they're both dropping down, right? The sun is slowly overtaking the moon. Now see, bang, Iceland, maximum totality. This is when the sun is directly behind the moon, and it's a straight line down to Iceland, and then it carries on. The sun slowly overtakes the moon, and the shadow goes up like that. Whoosh, Gonski. I have busted my ass trying to make it work on a globe. It doesn't. It's impossible. It doesn't work. It doesn't happen. Tonight, I'm going to send out some questions. Simon Dan, but explain it. Show it with a globe, please. Show it like this. Show it on the globe and do this. It doesn't work. It doesn't work. It doesn't work. Don't people want an explanation for how a solar eclipse is playing out? The moon's shadow up in the Arctic? It's an insult to people's intelligence, and still no answer from anybody to how it actually happens. All right, folks, I will be back. Please be under 30. 29, 21. Okay, that's good. Time to get one more real one. Go. See that? Right, folks. Question time. Laters.